Hi, everybody. So as you know, this is completely optional, but I figure it would be very helpful for you to do it. So let's go through this. The first question asks for making TAE buffer, and we're going to need 500 milliliters of it. So the recipe is here. 40 millimolar tris, 20 millimolar acetate, and 1 millimolar EDTA. So as usual, we're going to start with the quantity that we need, which is 40 millimolar, 20 millimolar, and 1 millimolar. But remember, we need actually to be in moles per liter. So that's going to, the 40 millimolar is going to be 0.040 moles per 1 liter. And then we're going to do our conversion factor of, it's to get rid of the liters. So 1 liter over 1,000 milliliters. And then we're going to multiply by the molar mass, which I've got as 121.14 grams per mole. And then we're going to multiply it by our final volume, which is going to be 500 milliliters, or half a liter. So just to confirm, our liters are going to cancel, our moles are going to cancel, and our milliliters are going to cancel. And that's going to leave us in an answer with grams. So now we can just do some calculation. 0.04 times 121.14 times 500 divided by 1,000. We're going to need 2.42 grams. And sig figs I'm not too worried about, only because I don't have the room over there to write more. But if you have more, that's fine. Give myself some more space here. Enter and enter. All right. So next, for the 20 millimolar acetate, we're going to do essentially the same thing. We're going to use the molar mass that is 59.044 grams per mole, and we have to convert again from 20 millimolar. We need it in moles, so 020 moles per liter times the conversion factor to get us out of liters, 1 liter over 1,000 mils. And then we're going to multiply by the molar mass, 59.044 grams per mole. And then we're going to multiply it by the amount we need, which is 500 mils. If you want to put it over 1, that's fine, but I never do because it looks a little cumbersome. So just to confirm again, liters cancel, moles cancel, mils cancel, and we're left with an answer in grams, which is what we're going to go measure. 0.02 times 59.04, enter, times 500, enter, divided by 1,000. That's going to be 0.5904 grams. I'm out of space, so I'm going to go with 0.59 grams. And then finally, for the 1 millimolar, same deal, 0.001 moles per liter, times our conversion factor, 1 liter over 1,000 mils, times the molar mass of 292.24 grams per mole, times our final volume, 500 mils, and that should be 0.001 times 292.24 times 500 divided by 1,000. It's going to be 0.146. It's actually 0.14612, but I can't fit that. 0.146 grams of EDTA. So you throw that all, 2.42 grams of tris, 0.59 grams of acetate, and 0.146 grams of EDTA. You throw that into a bottle and you fill it up to the 500 ml line, and that's with water, and that's going to be your 50x TAE buffer. The next question is, well, now that I've got that, how are we going to prepare 100 mils of 1x TAE from that stock? So this is basically the big tell here about what you're actually, or why you're going to use the following equation, is the fact that we're dealing with a stock solution. So the second you have a stock solution, you're going to have some solution that's in, a cabinet somewhere, and you're going to have to dilute that. And anytime we're diluting it, you're going to do C1V1 equals C2V2. So our concentration to start is 50 times more concentrated than it should be, so I just write 50x. You don't really do anything with the x, that's just reminding me that it's 50 times more concentrated, times that volume that I want to find out, equals the 1x times how much of this stuff do I need? 100 mils. So we're going to do a little bit of algebra, divide both sides by 50. Both sides by 50, and you could do 50x, but the x really, again, it's a label. It's like millimolar or grams or whatever. It's not a part of the equation. So that gets divided, and last time I checked, 1 times 100 is 100 divided by 50 is going to be V1 is going to be 2 milliliters of this stuff. So all we have to do is take 2 mils of that 50x TAE that we just made, and then put it in essentially 98 mils of water. Okay. So another big one. I have the molar masses for us. So let's just dig right in. 25 millimolar tris, and our final volume is going to be 2,000 mils. So our first piece is going to be 0.025 moles per liter times 1 liter over 1,000 mils times the molar mass, which is 121.14 grams per mole, times our final volume, which is going to be 2,000 milliliters. Again, to check, liters cancel, mils cancel, moles cancel. I'm left with grams, which is good. Now we just do the math. 0.025 times 121.14 times 2,000 divided by 1,000. That is going to be 6.057 grams of tris. And then the next piece is going to be 0.192 grams per liter. Moles per liter times 1 liter over 1,000 mils times the molar mass, 75.07 grams per mole, times the 2,000 mils. Moles will cancel, liters will cancel, mils will cancel, and we're left with grams. So 0.192 times 75.07 times 2,000 this time, divided by 1,000 is going to be 28.82 grams. And then this third one, this is a big tell, we've got a percent. So when we see a percent, we're going to set up a ratio. 0.1% is the same thing as 0.1 over 1,000. Or, I'm sorry, let's try that again. 0.1 over 100, so 0.1 over 100, that's 0.1%, equals x over, how much do we want? 2,000 milliliters. Okay, so we're going to cross multiply. 0.1 times 2,000 equals 200 divided by 100, because we're going to have 200 equals 100x, divide both sides by 100. X will equal 2 mils. So what we're going to do is we're going to put 2 milliliters of SDS. I'm sorry, weight per volume. That's not mils, that is grams. 2 grams of SDS powder into 2,000 mils of water. And that would be how we would make this. So we would add this powder, and this powder into a big old beaker that can hold 2,000 mils, and we dissolve all 3 of those powders. Okay? Next one, how would we make 75 mils of lysis buffer? We'll start off with, actually, I'm going to give myself some more space here. Give me some real estate so I don't have to write so small. Okay, so now 0.05. moles per liter times 1 liter over 1,000 mils times 121.14 grams per mole times 75 mils is going to equal something. Again, liters cancel, moles cancel, grams don't cancel. Let's take that back. Mils cancel. And now we just do the math. 0.05 times 121.14 times 75 divided by 1,000. 0.454275, but I'm not going to fit it grams. Okay, next up is going to be 25 millimolar sodium chloride, so 0.025 moles per liter times 1 liter over 1,000 mils times the molar mass, 58.44 grams per mole, times 75 mils. Again, mils cancel, moles cancel, liters cancel. 0.025 times 58.44 times 75, enter, divided by 1,000. It's going to be 0.109 grams of salt. And then 2 millimolar is going to be 0.002 moles per liter times 1 liter over 1,000 mils times the molar mass, 292.24 grams per mole times 75 mils. Mils cancel, moles cancel, liters cancel. 0.002 times 292.24 times 75 divided by 1,000. 0.04386 grams. So I hope you got all three of those, and we would bring that up and we would add those into 75 mils of water. The last three are actually pretty simple. I would like to make, or how would I make 25 mils of 500 millimolar hydrochloric acid from 12 molar stock? Again, there's your tell. We got a stock solution, so C1V1 equals C2V2. C1 is going to be 12 molar. V1 is what we're looking for. C2 is going to be 500 millimolar, but because we're in molar here, we have to be in molar here. So 500 millimolar is 0.5 molar times V2, which is, we want 25 mils. So we're going to end up with an answer in mils here. 0.5 times 25. And we're going to divide both sides by 12. So we're going to have 1.04 mils of So I hope this didn't screw up, but my battery died. So let's see what we can do. So 1.04 milliliters of hydrochloric acid concentrate, and then we would bring that up to 25 mils with water. So the next one, how we make a 0.8% weight to volume agarose gel using agarose and water, and I believe on the sheet it says 20 milliliters. So weight to volume, 0.8%, 0.8 over 100 equals x over 20. 20 times 0.8, multiply. 20 times 0.8 is 16 divided by 100. It's going to be 0.16 grams of agarose into 20 mils of water. And then finally, how would I make a 100 ml bottle of bleach, 10% bleach? So again, we've got percent volume to volume. 10 over 100 equals x over 100. So 1,000 cross multiply. So 10 times 100 is going to be 1,000 equals 100x. And then divide both sides by 100. You're going to get 10 mils of bleach, plus 90 mils of water. All right, so I hope that helped. I hope you did well and you're going to be ready for the exam on Tuesday.